So picking up from where we left off, here's a many body problem. How can I tell? More than one mass. I'm going to start out the same. I'm going to label the forces. If there's more than one mass, almost always, Quinn, I'll give you the picture. So rather than draw a separate free body diagram, I tend to just label my picture because it's easier to keep track of stuff. So we go like this. What are the forces acting on mass 1? Get the obvious one. We have M1G. It's not sinking into the ground like quicksand, so we have normal force number 1. We have, since there's 2 ropes, I'll call it tension 1. And I'm pretty sure this thing is sliding to the right. There's no way it can be sliding to the left because objects don't pull things up a cliff magically. Things hanging over a cliff tend to pull things down the cliff with it. So I think friction, and I'll call it friction force number 1, is pointing that way. What are the forces acting on mass 2? Get the obvious one. Well, I'm going to say M2G. Is this mass sinking into the ground like quicksand? Is it flying into like Superman? So vertically, the forces must be balanced. That's our argument for the fact that there must be a normal force. And since it's mass 2, Jake, I'll call it normal force 2. What else? Well, there's a rope pulling it to the right. This is the second rope, so I'll call it tension 2. There is also a rope tugging it to the left. This is tension 1. This is a Newton's third law, forces come in pairs force. Oh, and there would also be friction force number 2. Then I look at mass 3. What are the forces on mass 3? Get the obvious one. Okay, so we're going to have M3G. What else? Is there a normal force on mass 3? No, it's not sitting on a surface. Oh, is there a rope attached to it? Well, hey, we'll call that tension 2, because that's what I call it on the other part of the rope. Who's winning? So anything that ends up pointing down once we get over here is going to be a winner plus. Anything that ends up pointing up when we get over here is going to be a loser minus. And I'm going to write a big force equation for everything. I zoomed in. I'm going to zoom back out just so I have a bit more room to write, if that's okay. And it's going to look like this. So M3G, winner. This force, and I'm going to write all along the rope. So you notice, by the way, Jose, I'm not saying vertical or horizontal because this pulley allows these forces to be vertical and these forces on the rope to be horizontal. I go along the whole rope. Is that all right? Hey, tension 2, winner or loser? Positive or negative? Negative, loser. What about this tension 2, winner or loser? Winner plus. I'm going to relax. Tension's going to cancel out, but I'll still draw it in just so I can see where it showed up. And also, it lets me use that stupid joke. Friction force number 2, winner or loser? Loser, negative. Then I run into tension 1, pointing to the left, winner or loser? This tension here. Loser, negative? Oh, but then I run into tension again. Tension 1 again. Winner or loser? Winner plus. I said tension 2. I should have written tension 1, right? Oh, and then I run into one more force. Friction 1. Winner or loser? Equals, there's going to be an A over here. You know what? It's going to be the mass of all of them times A. It's going to be M1 plus M2 plus M3. But you can, by the way, I would have no problem, Mac, if you decided to write M1 plus M2 plus M3 times A, because I'm going to do that later on, but I have no problem if you get a wee bit lazy and you say, hey, M all times A, whichever you want to do. Tyler is yawning. You know why? Because he's all relaxed and comfy. Why is Tyler relaxed and comfy? Because, baby, he's losing tension, and he's losing tension. I like that. Love it when tension vanishes. Ah. What's part A asking us to find? How would I get the A by itself? Okay, can I do that on the next line? I'm going to be a little dangerously. I'm already going to say A equals, and I'm going to go divide by M1 plus M2 plus M3. Is that all right? Okay. Now let's start dropping these into the equation. So the first thing I see is M3G drops down minus friction force. Friction is what times what? So this is going to be mu times normal force number 2 to go with friction force number 2. And I notice I didn't put a 1 in my equation on the second friction force. I should have, just for fussy notation, because it's going to be minus mu friction force number 1. Oh, not friction force number 1, normal force. Whoop, that wasn't good. Normal force number 1. And that 1 kind of looks like it's hovering in midair, so let's put it right. That's better. I got a problem. I don't know normal force number 2. Oh, but look. I know the force is the same size as normal force number 2. Which one is the same size as normal force number 2? Okay, so I can go like this. It's still all going to be over M1 plus M2 plus M3. By the way, I strongly encourage you all to get your calculators out, because we are going to try typing this in one fell swoop, and I want you to learn how to do it. You're going to see if you can pull it off with that sorry excuse for a calculator. It's going to be M3G minus mu. What's normal force number 2? M2G minus mu. What's normal force number 1? M1G. I left a whole page, right? Yeah, good. Is that okay so far? Now let's plug and chug. The acceleration is going to be, I've scrolled down. What was M3? 5? I don't use a negative. I've taken care of all that in my winner minus loser approach. Minus, what's mu? I don't know. What's mu with you? What was mu? 0.2. And mass 2 was? 3. I know G is 9.8. Minus mu is 0.2. What was mass 1?
4.
G is 9.8. All over 4 plus 3 plus 5. If you really wanted to, you could do that in your head and just write a 12 there. But if it was yucky decimals and things, I'll show you how I would do it. Now, I wrote brackets for timesing when I hand wrote this. But Riley, on my calculator, I'm going to use my times sign for timesing. But is there more than one thing on the top of this fraction? Brackets around the whole top. Is there more than one thing on the bottom of this fraction? Brackets around the whole bottom. For me to crunch this, for me to solve this, I'm going to type as follows. And you should be able to, Rob, do it this way. You just won't have the same display that I have. Bracket. 5 times 9.8 plus, Mr. Dewick? Take away, nice try. 0.2 times 3 times 9.8. Take away 0.2 times 4 times 9.8. Close off the top. Divided by bracket 4 plus 3 plus 5. Close off the bottom. Try typing that in, because this seems to be where kids start to make calculator mistakes. I got an acceleration of 2.94. Now, what if I got a negative answer? I guessed the wrong winner, which wouldn't be that hard to fix. All I would do is I would make this a loser, put a negative in front of it. I would make this a winner, put a positive, make this a loser, put a negative. It's actually not a hard fix. Okay? That's why you may recall in the last lesson I said, I asked, how can we figure out which way things are going to move? And you're going to find in more complicated ones. I'll show you how you can figure out ahead of time. But truthfully, Colin, I'll usually just guess, solve, and if I guess wrong, it's a pretty easy fix. It's quicker to do the fix than to spend the time calculating ahead of time which way it should move, which is maybe bad physics, but good test writing. 2.94. 2.94 what? It's an acceleration. Now, if you didn't get that, snag me later and we'll type it in later. But that is the answer to part A. What did part B want me to? There was a part B, wasn't there? Oh, tension on each chord. Okay. You know what? I'll find tension 1 on the left. I'll find tension 2 on the right, since there's 2 chords. I think I would find tension 1 using this mass. I know it appears here. I would find tension 1 using this mass. So I'm going to write an equation just for this mass. Which way is this mass accelerating? So who's winning? On this mass only, which force is tension? Which one? 1. Who's losing? So if I hear you correctly, and I think I do, you're telling me tension 1 minus friction 1 equals not the mass of all of them. I'm only looking at mass 1, so it's going to be M1A. How would I get tension 1 by itself? Okay, so it's going to be tension 1 equals M1A plus friction force number 1. You know what? Friction force number 1 up here. Friction force number 1 up here was mu m1g. So can I do that substitution on my next line, if that's okay? By the way, in your homework, Justin, if you want to plug in numbers a little sooner, you can. On a test, I tend to plug numbers in last because I find I make my dumbest mistakes with the numbers, and I want to get as many part marks as I can. And in our notes, we'll show every single step here so we know what the heck we did. So it's going to be tension 1 equals M1A plus mu M1G plus this time. What was M1? 4, is that right? A was, you know what? I'm not going to fit this in on one line. Let me erase this. I'll put it here. 4, A was 2.94. Now, if we had rounded off that 2.94, Lewis, I would use my answer button there, but thankfully this worked out quite nice. Plus, what's mu? I don't know. What's mu with you? 0.2? 4 times 9.8. Dope. 19.6? Oh. Every time I see 19.6, that's 2 G's. So I just, oh, that's kind of convenient. It's falling at twice. No, its tension is twice the force of gravity on it. 19.6 what? Tension, newtons. Okay. Tension 2. I could find tension 2 using this mass or this mass. Which mass isn't as yucky? I think I'd go with this one. Even though tension 2 is a winner in this one, and mathematically it'll be easier to get by itself, I'm going to have to then also include friction, and I'd be using tension 1 to find tension 2, and if I got tension 1 wrong, I'm going to get tension 2. So last class I said to you, I usually use tension as a winner to find tension. I lied. I use whichever one is less cluttered. Who's winning over here? M3G. Who's losing? Tension. So my equation over here, tension 2, my equation over here is going to be M3G minus tension 2, and that's going to be M3A. Jordan, I think we've seen this dance before where tension was the negative. I think you've seen me say, hey, I'm going to plus this to this side whilst at the same time minusing that to that side. I think I've done that dance a few times before. In other words, the M3G will drop down. There's going to be a minus M3A A, and over here on the right is going to be tension by itself, except Justin, I'm going to be even more clever. I'm going to put the tension over there, because we're used to seeing it on the left on its own. You could have left it on the right. I'd give you full marks, but let's make it look all prim and proper. And now it's plug and chug. What was M3? 5? 9.8 minus 5, 2.94. I might even be able to do this in my head. It's going to be 9.8 take away 2 is 7.8, 6.9, 6.86 times 5. 6 times 5 is 30. 6 times 0.8, 34. 37? Am I right? 34. Wow, I'm way off. Really? I got to check that. Not that I don't trust you, but you were like yawning earlier today. You like notice everything, Mr. 34.3. Holy smokes, Ty is right. I mean, Ty, you're right. Good for you. Tension 2, 34.3 newtons. As part of today's lesson, we're going to ask, hey, Carolyn, what if I give you the tension, but don't tell you the masses? Can you work your way backwards? And the answer is, yeah, you'll reverse this whole procedure. You'll actually use the tensions to find the masses, and then you'll use that also to find accelerations. For now, can you add to the homework that I assigned last day? I think you can go with, I'm going to skip 7 because all 7 wants is the equation. I'm going to skip 8 because all 8 wants is the equation. 9 is good. You know what? Skip A, 9B, because to find the acceleration and chord tension, you're going to end up writing the equations for each mass anyways. So 9B. 10, skip A, B. What I'm really saying is to find the acceleration and chord tension, you're going to have to write equations for the masses anyways. You know what? I'll skip 11, but I'll do 12B. It looks like 12B, you got 2 different mu's. One, you know what? I'm guessing the 3 kilogram block is made of like really smooth marble, and the 4 kilogram block is made of something that's much rougher. Maybe it's coated with sandpaper on the bottom or Velcro or something, and so it's got a higher mu. 13 is tough. See if you can figure it out. And 15 is finding a missing mass. I haven't done that with you. I will in about 10 minutes. So, I skipped 14. You can cross 14 out. You can try it if you want. Sorry? Well, you know what I'm doing for most of these? I'm only assigning B. If it says write the force equations, I'm going to say, you know what? Do that as part of your finding the acceleration. Find a system that works well for you. Rarely will I ask you on a test, could you just give me the equations and then quit? Usually I'm going to say, hey, tell me the answer, and please, here's a good method that works. Is that okay? Now, pause. So, lesson 5, the Atwood machine. What's an Atwood machine? An Atwood machine is the name we give in physics to a pulley system like you see in the picture below, where mass 2 acts as a counterweight. In fact, an elevator is a great example of an Atwood machine. In an elevator, the car that you get into, you don't realize, but on the other end of the cable, there is a mass that's identical to the car you got into. All the electric motor has to lift then are the people in the car, because the mass of the car itself cancels itself out. This is an Atwood machine, except, Lewis, we're in our magic physics world. What do I mean by that? You know how much the cables weigh? Nothing, because that would be yucky math. Oh, you know how much the pulley weighs? Nothing. You know how much friction there is in the pulley? None, please. So we're in our magic physics world to keep all the math nice. You see, in real life, if this was a huge cable, the further this went down, the heavier this cable would be, and that would change the whole equation. Every centimeter that it moved, the overall mass would be changing, and you need calculus to solve that. Okay? So an Atwood machine is a frictionless, massless pulley in our magic physics world with a frictionless, massless cable system. But for what it's worth, mass 2 is called the counterweight. So here's example 1. First question. Suppose you put equal masses on either side of the Atwood machine, and then you lift one mass, this one, so that it's higher, and then you let it go. When you release it, how does the system move? A, the system remains at rest. B, the higher mass will fall down. Or C, the lower mass will fall down. The higher mass will go higher. So we have identical masses. When released, how does the system move? You know what? Since there's A, B, and C, this is a good chance for us to exercise our voting democracy. How high you hold your hand up is how sure you are of the answer. I'm ignoring your question on purpose. I'll get back to you afterwards. Okay? So we have identical masses. This is our Atwood machine. We're going to lift this one up. When I let it go, will it A, remain at rest, B, higher mass go higher, or C, higher mass fall down, or C, higher mass go higher? Okay. Who says A? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, we're going to say long. Who says B? Who says C? Okay. Convince me.
I still have a question.
What's your question?
Do you stop it when you drag it up? And,
I would then bring it to a stop. I wouldn't shove it up and keep it zing like that. I would stop it and then let go.
Yeah, so then it's right.
Convince me. Yeah.
Equal forces on both sides.
You know what? I think this is a job for a good free body diagram. In fact, I think I can answer this with no English. All equations, and the nerd within me likes that, and for my ESL students that's also helpful, but also for my non-ESL students, we're now starting to talk about the concept of a proof. Although I said a free body diagram, did they give me a lovely picture here? I'm going to label the forces on this right-hand one. What are the forces on this? Get the obvious one on the left-hand mass. Gravity, mg. Oh, is there a rope? Tension. What about the forces on the right-hand mass? Get the obvious one. Gravity. Mr. Dewick. Yeah, Rob. There's two masses. Yeah. Why didn't you call them M1 and M2? Because both masses are identical. I can use the same letter for both of them, can I not? See how I thought that through? Oh, and Rob, you'll agree, tension? Okay. Who's winning? You know what? We're not sure. Let's pretend B is correct, and then let's see if we end up with a contradiction. So I'm going to pretend that this is winning, because the higher mass is going higher, the lower mass is going lower. That must mean that that is okay. So I would go like this. mg, anything that ends up pointing down when it gets to the right-hand side is going to be a winner plus. So this tension is a loser. What about this tension? Now, at first, you might think it's a loser because it's pointing upwards, but follow it, follow it, follow it, follow it. When it gets to this side, which way will it end up pointing? It's a winner. And again, you might be tempted, Tyler, to say that this left-hand mg is a winner because it's pointing down, just like we said, down is winning. But follow it, follow it, follow it, follow it. When it gets to this side, which way will it end up pointing? When it gets to this side, it's going to end up pointing down. It's right? Because it turns an entire corner. So it ends up being a loser. And that equals 2 masses times A. M1 plus M plus M. What do you notice about the left-hand side there? You get this. Now, how can you get 0 when you multiply? On the right-hand side, we're multiplying. Well, the only way you can get 0 as an answer is if one of these is 0. Are the masses 0? What must be 0? There's my explanation. a good diagram, 2 lines of work, and a conclusion. Now, going back to Leonard's question, by the way, if A is 0, they could keep going at a constant speed if we kept it moving, because that would still be A is 0. And that's why I figured you were going there, which is why I tried to ignore it for a little bit at first. Thank you. Okay. So here's an Atwood machine. It says, in the diagram below, assume mass 2 is 5.8 kilograms and mass 1 is 2.3 kilograms. Solve for acceleration and find the tension in the cord. Okay. Any suggestions on how we're going to start this? Wow, let's label the forces. What are the forces acting on mass 1, Matt? Get the obvious one. M1G. This time the masses are different, so I'll go M1 on M2. Is there a rope? Tension. Is mass 1 touching the surface? So no normal force. If it was, I would include a normal force pointing up, but I can even find for that. I think there's one in the homework where you have to try that. Mass 2, M2G. And tension. Who's winning? The heavier mass. Who's winning? M2? So anything that ends up pointing that way when it gets to the right-hand side is going to be winner plus. Anything that ends up pointing upwards when it gets to the right-hand side is going to be loser minus. So what's my equation going to be? M2G, and now I'm walking along the rope. I run into tension. Yep, go ahead. Winner or loser? Loser. What about this tension? Again, you might be tempted to say it was a loser because it's pointing up just like this guy, but follow it, follow it, follow it, follow it. When it gets to this side, which way will it end up pointing? Down, right? It turns the corner. So it's going to be a winner plus. What about M1G? Again, you might be tempted to say, well, down, winner, but follow it, and when it gets around the corner, which way does it end up pointing? Got to use your imagination a little bit, but you guys can see it ends up pointing up, yeah? It ends up being a loser. Have we done more than one mass on the left-hand side? Then I better have more than one mass on the right. Or you could write M all. Gotta love it when you lose tension. What's part A asking me to find? Can I get the A by itself on the next line? Is that, how would I get the A by itself? Divide by the bracket, right? So I'm going to do that on my next line already. I'm going to go A equals, and I'm going to put the bracket down there. And then dropping down M2G minus M1G. Oh, no friction. You know what? This isn't too bad. This is going to be, how much room do I have, by the way? Oh, I left a lot of room here. Good gosh. Mass 2 was 5.8 times 9.8 minus 2.3 times 9.8 all over 2.3 plus 5.8. Again, this is one of those, I would encourage you to get your calculator out and try this. Is there more than one number on the top? Yes, brackets. Is there more than one number on the bottom? Yes, brackets. Is that a hand up or just, no? Oh, sorry, I thought you were, thought I saw that coming ready. Okay. So I would type a big open bracket, 5.8 times 9.8, take away 2.3 times 9.8. I would close the bracket off, divided by, I would open up a bracket, 2.3 plus 5.8. I really want to encourage you to learn how to do this in one fell swoop. Some of you are, well, why can't I type the top, hit equals, type the bottom, hit equals? Because sometimes the decimals will be long and yucky, and you'll be rounding off, and I want to teach you how to do this without rounding off. And I got that. No? Yes? Oh, 3 sig figs, 4.23. But I'll use my answer button later on for if I need acceleration. Again, I'll store this on my calculator. Is it working okay for you? Yep. Well, that's amazing. I mean, good for you. 4.23. 4.23 what? It's an acceleration. Meters per second squared. There's part A. Part B. says find the tension. There's tension on two masses. Both of those masses only have two forces. So in terms of level of difficulty and yuckiness, they're the same. So which one should I pick? I would pick the one in which tension is a winner. In which one is tension a winner? My equation is going to be tension minus M1G. Is that okay, Colin? Yeah. Equals M1A. Why didn't I include M2? I'm only writing an equation for a single mass to find the tension. Oh, how would I get the T by itself? Plus it to that side. Tension's going to be M1A plus M1G, which is going to be M1 2.3. A, I'm going to write 4.23, but I'm going to use the answer button on my calculator. Plus 2.3 times 9.8. And I get 32.3 newtons. That's the Atwood machine. Turn the page. All right. Consider the following system, it says. Which of the following is the best force diagram for mass M2? A, B, or C? You know what? I think I'm going to just literally do a force diagram for this whole thing and see which one is right. Although, I can eliminate one of these right now. Can you see which one of these, A, B, or C, that I can get rid of right now? Why C? Definitely this thing is accelerating to the right. Can C possibly be accelerating to the right, or are all the horizontal forces balanced? So I would say, nice try, no. Okay. Well, what are the forces acting on mass 1? Get the obvious one. Zoom in so you guys can see. So I would definitely have, is it sinking into the ground like quicksand? No. Is it flying into like Superman? No. You know what? I think I can also say, now here's the F applied. Normally, I don't draw arrows pointing towards. I like to have the, normally I would have liked to have drawn it like that, but I'm okay. You know what? That's going to clutter up this one, so I'll live with it right here for now. Is there friction? No, if there was, I'd just have another arrow pointing to the left. Okay. What else? What's happening right there? They're pushing into each other. Those two pushing into each other forces, Devon, are going to be equal. Newton's third. Here's what I call that. I don't really want to call that a normal force when I also have the ground. We did, when we did our book against the glass, we called it a normal force because there was no ground in the equation. Here I've got the ground. I want normal force to be pointing up. I tend to call this F con for contact. I call it a contact force. A push. They're bumping into each other. Okay? Hey, what are the forces acting on mass 2? Get the obvious one. Is it sinking into the ground like quicksand? No. You're saying there's a normal force number 2? Sorry. Folks, I drew this F-con pointing the wrong way. This is pushing against the mass 2. Which way is mass 2 pushing then? You know what? F1, sorry guys, can you do me a favor? Scribble or erase that out. That's my bad. Mass 1 is feeling a contact force pushing this way, and it's mass 2 that is feeling a contact force pushing that way. Where those two are pushing into each other, they push against each other, but I forgot that I like to draw the arrows going out from the masses. Those three forces in red are the forces acting on mass 2. In fact, you know what's pushing mass 2? Not the applied force. What's causing mass 2 to accelerate? This contact force. What's the correct answer, A or B? A. It says explain your answer. We did up there in our free body diagram. Okay. Another thought experiment. A curling rock, so we're looking straight down from the top and it's on ice. It's sliding to the right, east, across a sheet of frictionless ice. It bumps another rock and it experiences a force that acts very briefly to the north. What would be the path of this rock 1 after the bump? A, straight up. B, straight east, so straight north. B, straight east. C, a curvy path. Or D, kind of north and east. I don't know if your guys' has vanished, but mine... Does yours have an arrow connecting it properly on your diagram? Okay. I'll fix this diagram later today.
Did you,
What do you guys think? A, B, C? You know what? Let's vote. So, you have a question or an answer? If you have a question, to clarify, but don't give out the answer because we're going to vote.
No, I've got a question.
Yeah. So, if you, by the way, if you want to, you can make a little note right here. We're looking down at it. You don't have to, but just to... Yeah. Okay.
Rock 2 is accelerating up, and rock...
North?
Yeah. And rock 1 is accelerating to...
Not accelerating. So I'm going to correct both of you. Rock 1 is traveling at a constant speed due east.
Yeah.
Rock 2 could either be stationary or traveling at a constant speed due north. All I'm saying is it exerts a force on rock 1 exactly due north and very briefly. So the force only lasts for a short time, but the force it exerts on rock 1 is due north.
Due north. Okay.
Yeah. Okay?
Yeah.
Who says A? Who says B? Who says C? Who says D? Okay. If you have an unbalanced force, there must be a change in acceleration. Yes? Why can I cross that one out? The only way that your direction can be changing is if you're still exerting a force. If you're still, sorry, for you guys it's this way. If you're still exerting a force, that's why I included the word briefly. The only way that it could be curving is if you continued to push it, continued to push it, continued to push it. You may have noticed that if you ever, for example, had a heavy mass like a bowling ball, if you try and actually, once you get it rolling, change its direction, you got to push, 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 push. Okay? Why is A wrong? Well, the only way that you could go due north is you would have to cancel out all of the east, which means there would have to, somewhere in this question, be a west force. Is there a west force anywhere in this question? So where it says, using principles of physics, explain your answer, I think that's what I would do. I wouldn't quite give you a question like this to explain, though. Too much English in my explanation. I like ones where I can do a good free body diagram and an equation. Okay? Mr. Dewick forgot to bring the towel that he uses for this demonstration and the leaky water bottle that he uses for this demonstration, and it was totally his fault because he was doing Physics 11 prepping all weekend. So next class on Wednesday, adds an element of danger. If you're late on Wednesday, prepare to get wet. No, you know what? Lewis, were you late today? Excellent. You're not serving a detention today, but you're going to be one of my guinea pigs on Wednesday. You might get a little bit wet. Sorry. I like example 7. I like example 7. Example 7 is a nice question. How is example 7 different from all the other ones? Missing a mass. Missing a mass. I haven't asked you to find a mass yet. I did the last question of the homework from last day. You had to find a mass. Let's find a mass. You know how we're going to start? Same old, same old. We're going to label our forces. What are the forces acting on mass 1? Get the obvious one. Tension. M2G. Tension. If I know both masses, I write an equation for everything and I find acceleration. Do I know both masses? Say no, Rob. Oh, you know what? Then I'm going to start with the one mass that I do know. I'm going to write an individual equation for that and see if I can find other stuff. Which mass do I know? M2. And which way is M2 accelerating? Downwards? I might even go like this. I might even go like this, just to make sure I know. It looks like we're going up on the right and down on the left. I'm going to write an equation for mass 2 only. Looking at mass 2, who's winning, tension or M2G? Since we're accelerating down, and the question clearly says mass 2 is accelerating down, M2G is the winner. Now, why is that so helpful? Do I know mass 2? Do I know G? Do I know mass 2? Do I know A? You know what I can find? Now, why is that so helpful? Look, 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 look. Is there a tension over on this mass as well? I think then I'll be able to jump to mass 1, and I think I'll be able to solve for mass 1 only looking at mass 1. You with me? So the first thing I'm going to do is get tension by itself. Hey, we've done this a few times. Right? M2G minus M2A equals tension. M2 is 8.4, 9.8. Once again, not negative. I took care of all that. I decided to let down be positive because mathematically it was way more convenient. Minus 8.4 times 3.5. Do you get 52.92? I'll carry everything because I'm going to use, this is not my final answer, and I'm going to use this to find other stuff. So I'll carry all 4 sig figs. Okay. Now, write equation for M1. You can write that down, or you can, we're going to do that. So looking at mass 1, which way is mass 1 accelerating? Well, if mass 2 is accelerating down, which way must mass 1 be accelerating? Who's winning in mass 1? Okay, so ready? It's going to look like this. Tension minus M1G equals M1A. Do I know tension? Just found it. Do I know G? Do I know A? The only thing I don't know is M1. I should be able to solve for M1, except what's the problem? How many M1s are there in this equation? 2. How many would I prefer? 1. You know what? Let's get all the M1s to the same side. I can do that. How would I get all the M1s to the same side? What would I do with this here? Plus it over? I get tension equals M1A plus M1G. You're good. How many M1s are there, Justin? How many would I prefer?
1.
It'd be wonderful if there was a grade 9 mathematical operation that I could reach into my back pocket, pull out, and somehow magically change this from 2 to 1. And there is. What can I do? I can factor out a GCF. Is there an M1 in everything on the right-hand side? Then I'm going to argue, Jake, that I can go like this. By the way, this trick right here, Quinn, if you have the same variable twice in an equation and it's what you want to find, This is what I like. You're going to see this a few times this year. Get all the same variable to the same side. Factor it out, because now how many M1s do I have? Ah! And how would I get that M1 by itself? Divide by the bracket. Looks like do I know tension? That's why I had to go looking at M2 first. I had to find something that I could transfer over. Do I know the acceleration? Yep. Do I know G? Oh, I've known that since Physics 11. So 52.92 all over 3.5 plus 9.8. More than one number on the bottom. We'll have to put the bottom in brackets. I'll use my answer button, divided by bracket 3.5 plus 9.8. Mass 1, I think when I crunched this, I started with a mass of 3.98 kilograms and ran it all the way to the other side. Yeah, 3.98. And it's a mass, kilograms. So as far as I'm concerned, it is now, Tyler, fair game for me to give you two masses, tell you some more information, and say, hey, go find one mass, please. Okay. By the way, here, Tyler, I gave you mass 2, the acceleration, and you found tension and moved it over. Or I could have given you mass 2 and tension. You could have found the acceleration and then still walked over here. You'd have tension, you'd have acceleration, you'd have G. You can find M1. I'll always give you one of the masses, and then I'll either give you the acceleration, find the tension, or I'll give you the tension, find the acceleration. And for the mass that I gave you, then walk over to the other mass. Example number 1 we're going to do as my demo later on, because I've given you lots of homework today. So for now, the stuff from last day plus question 2. Question 3. Mr. Dewick, you haven't done one like that. Well, last lesson we had stuff sitting on surfaces. Today we have the Atwood machine. There, I combined them. A good free body diagram. By the way, how many ropes are there in that question? It's going to be 2 tensions, okay? Oh, I was nice, though. I did make it frictionless. Although if I'd added friction, it wouldn't be that tough. Rob, you'd have one extra force pointing that way, I'm pretty sure. It'd be mu times the normal force. I don't know the normal force. Oh, but look, and another force. I think I could handle it. It'd just be longer. But I didn't do that. 6 is good. So I've skipped 4, I've skipped 5. Okay, absolutely number 7. You're going to have an Atwood machine question. Little twist, number 8. If it's at rest, find the normal force. Find how hard the table has to be pushing up on the left-hand mass, on the 5 kilogram mass. This is a scholarship question. Here's what's happening, okay? Mass 2 is 12 kilograms. Mass 2 is on the left side for you. Mass 2 is really heavy. We start out like this, and I want you to watch this mass here. Mass 2 is going to fall. It's going to hit the ground really fast. And mass 1 is going to keep going up afterwards. Did you see some slack in the rope? How high will it go? That's a really tough question. I'm curious. Like, I'm not going to ask you one that tough on the test. Although technically it's all Physics 11, but it's multi step. See if you can figure that one out. If you can be a little bit proud of yourself. Number 10, here's a find a mass question. Okay, so lots of practice on this. No fancy videos. Next class, you're going to have a take-home quiz on everything up to and including today. And next class, Physics 12 starts. Because next class, instead of keeping everything flat and level, which we've done so far, we're going to, just like we did in projectile, we're going to go with angles. We're going to get tricky with it.